Thank you. Good morning, everyone, and thanks for coming to PWI. So when I was invited, I think it was more than 1 year ago, I was thinking, what should I say about the journey of onboarding the S&C and rail expansion devices, because at the time we didn't have any truck contractor or any S&C contractor. So, but now I'm pleased to say we are on the second leg of journey. We have a S&C contractor, which is VATT, and together I hope we will succeed in the second part of our journey. So a couple of things I want to talk about today. First, HS2 Project Overview. So just a couple of things about what is HS2. I'm pretty much, I think everybody knows, but just a quick overview of the basis. And then S&C Technical Challenges. So basically how we started this journey and where we are now. S&C and rail expansion devices design consideration. High-speed S&C componentry, a little bit about point operating equipment, conventional speed turnouts, obviously, as well as high-speed turnouts, and we have what I'm calling conventional turnouts as well, having depots and station and so on. A little bit about rail expansion devices, design facts and where we are with the rail expansion devices as well. Asset condition monitoring, Darren mentioned, and this is part of the scope which VATT will deliver for us, and it will be very important for maintenance and so on and so forth. And then at the end, just what's next for us and where we are going to do next. HS2. So HS2 will be delivered in 3 phases. So it's phase 1, which is linking London with Birmingham Curzon Street, which is, you can see in blue color. And then is phase 2A, a shorter phase, which will link Birmingham with Crewe. And finally, phase 2B, which will extend the line from Crewe to Manchester Piccadilly, which will be a new station in Manchester Piccadilly. Right, S&C Technical Challenge. So basically, High Speed 2 started this journey more than a decade ago, I think 13 years ago, if I'm correct, involving the industry and also academia and so on and so forth. So we have to start with writing the standards and not only for S&C, but for all the railway system components, civils, and so on and so forth. So one of the first challenge is the supply chain. So basically, worldwide, high-speed S&C have a very limited supply chain. So this is a first challenge to say, when you have to reach out, it's not much competition, I should say, which is again could be good or could be bad, But for a client, you have to have, the luxury, I should say, to choose from, But that's not always possible. So going and approaching, the potential supplier to make sure, they can deliver what you are expecting to deliver. It was, I guess, the first challenge. And then HS2, it's a first-class project with a very ambitious goal. So we set the bar very, very high, and I will tell you why. Because we will be the first high-speed in the world to run trains of 360 kilometers per hour. And operationally, the plan is for when we'll be completing 18 trains per hour. So that sounds like a high-speed metro in terms of timetable, but the speed is not quite for a metro. So that was another challenge. Another one was the diverging speed. Because of the operation timetable, we have to have 230 kilometers per hour on the turnout route, which again never been developed before. So you can see only a couple of things. Because of the speeds, again, we have slab track on phase 1 and phase 2, so we'll be all the way slab track. So the S&C will be either on precast or cast in situ, and depends on the area. That's quite challenging. It's only to say few things. Couple of design consideration for switch and crossing. So one, when you look at the design consideration, one of the main things is to look at the footprint, basically. So we have limited amount of land to design and build everything. So having only the longest S&C, the one which I just mentioned, it's around 220 meters, so more than the size of the football pitch. So you can imagine how long it's one S&C. So the angle of the switches and passenger comfort, to name so that was a main criteria as well. So VATT has what is called the clotoid entry switch, which basically have a jerks or a rate of change of acceleration below 1 millimeter per volume second. So it's having an acceleration less than 1 millimeter make a smooth movement from a curve or from a straight to the switch, and you will not spill your coffee on your trouser on your journey from London to Birmingham. So and missing your business meeting. So that's putting the joke aside. That's a very, very important part of the design consideration, which is passenger comfort. And if when you travel on our national network, sometimes you feel when you enter on S&C, that sudden lateral movement, which is not quite pleasant. Another design consideration, having these long switches, is the crossing. So we have for high speed, all the crossing, they are swing nose crossing, so very long, and many motors around to move them. So the number of the motors, again, depends on I will talk a little bit later, depends on the length of the turnout. So one of those, I think it's 30 motors for the longest one. So you can imagine the amount of space you need for that. I was talking about the switch entry geometry a little bit earlier. So that's make, as I said, the transition smoothly when the train is moving from a straight to a turnout. Another very important component is what is called the fake-up, which is a term to define the gauge optimization for a switch. This is a special design which is optimizing the gauge and also the wheel wear, reducing the wheel wear and increasing the passenger comfort. So the switch entry together with the fake op, make a much smoother running of the train on high-speed S&C. High-speed S&C componentry. So this is, again, very important on a long term, what components and you have, and how you assemble them, how they work or working together, and so on and so forth. So material and from base plates, special base plates, and switch rollers, because that the movement it's very important, and how the wear it's controlled, and so on and so forth. Swing down crossing, being such a large component, and how it's moving along, it's very important as well. So I'm not going to go in the very details, because I'm pretty sure my colleagues from VATT will I don't want to spoil their presentation. So Mainline POE, I mentioned a little bit. You can see the amount of that I mentioned already. It depends on the lengths, and so the longest one, which I said, will be around 13 POE. So for the mainline, we will have we choose the EcoStar, which is basically VATT point operator for high-speed line, and for depot, we will use the Unistar, which are, suitable. I think Nicoara is using that as well on their system. So POE, why are so important? Because not only moving the switch, you can imagine having such a long switch, with locking device and everything else. It's how it's moving, how it's putting in the real position. It's safety equipment as well as so it's so important to have the right numbers of the POE and doing the right job for you. Next convention, as I mentioned, conventional speed turnout. So one of the benefits also working together with VATT so far. So they developed what is called UHPC, so ultra high performance crossings, which I was really keen to explore with VATT and introduce this for our system, and also for some of the conventional S&C on HS2, because you can imagine replacing a swing nose crossing with the ultra high performance crossing. You eliminate not only a very expensive swing nose crossing, but also you remove the number of motors as well, which belongs to a swing nose crossing. So as far as I know, they already installed in Germany on Deutsche Bahn high-speed lines, and also earlier it was installed on Nicoara infrastructure, which I've been told we can go and see, how it's working and behaving in real time. So this is a real benefit. This was introducing in our system very early. But this is how we should listen to our contractors and implement new things and be able to to explore new things as well. Rail expansion devices. So rail expansion devices are, if you ask a truck engineer, it's something which we don't want to have on one of the piece of infrastructure which are very, very, sensitive, I should say, the least. So, but in a lot of cases, and HS2 is not exception. We have only on phase 1, we have 76 rail expansion devices all along the route, some of them on curves with high cant and also, 360 kilometers per hour. So, but, it's, and on slab track, like as you can see in the image there. So having them installed properly and maintained, it's very, very critical. And also choose the length of the expansion as well, so it can be RD 300, 600, and 150, 300, and 600. So basically, the 600 allow a movement of 1.2 meters, so which is quite a lot when you think about expansion of the bridge. This is about just a little bit more about asset condition monitoring, because I'm pretty sure other colleagues will talk about, but I think I thought it's very, very important to mention. So together with the S&C and rail expansion devices, VATT will provide us asset condition monitoring and for S&C and rail expansion devices. So this HS2 decided we decided to break this in 3 areas. So basically, for the main lines, what we are going to monitor and so on. So we have, on the turnouts, all over in the point operator equipment, we have rail temperature monitoring, rail and ambient monitoring, and we have data logger where data is connecting to the EMS system, and then the maintainer take the data and also look into things like plan. So which is the best. So you don't have to have unnecessary preventive maintenance, and also to plan much better for corrective maintenance, which is so this is asset condition monitoring is, I think it's a must for every system, especially not only for high speed, I guess for any conventional railway as well. So and then we have of course for the rail expansion devices as well as S&C, we have asset condition monitoring, looking at the rail temperature again, looking obviously we need to monitor the movement of the S&C, of the rail expansion devices, any displacement, looking at the bridge gap, bridge transition, and so on and so forth. So, so the system is in place, and it's once put it in there, it's there to stay, and it's there to help to maintain the system. So asset condition monitoring, in my opinion, need to be not only on S&C and rail expansion devices, but also on the entire rail system, looking at the bridges, looking at the tunnels, looking at the rail in tunnels and viaducts and so on and so forth. What's next? So I mentioned a little bit at the beginning about the journey. So pretty much we are on now what I call the second leg of the journey in terms of strategy and also involving more the industry, the academia, and so on and so forth. So just before we have it, we started to have with the University of Birmingham, we have a report done on a train simulation, basically. Well, it was a carriage simulation on traveling on rail expansion devices with high count and 30 360 kilometers per hour. You can see some nice picture about behavior of the simulation and what was considered. Now, all these, having said that, all these data help us and will help also our colleagues from VATT to design and also manufacture the rail expansion devices, because as I said, this is not having proven anywhere at these speeds. It will help us also with the test and commission as well. So next steps will be again going back to to Ukraine, and which we are partnered with. Now having the the S&C and rail expansion device contractor on board, we know what rail expansion devices they are proposing to us, but also we have the train manufacturer as well on board. So that means we can use a real train with a real wheel, I should say, and not only one carriage, but a set of carriage, forming a train, and see actually simulating, what is the wheel-rail interface and what is the RCF, so the interaction between the wheel, what is going to be the movement of the train, traveling on such a high canted curves and so on and so forth. So basically, as I said, this is just the beginning of a second leg of the journey. I'm quite pleased to report that we managed to to finalize one leg, just to carry on with the next leg. It will be more challenging, to work together with the S&C contractor and to bring, the truck contractor as well, to see the slab trucks and everything else coming on board, and with the train manufacturer as well. So basically, that will be all for me. That's the end of the presentation, and thank you very much for listening.